What causes rheumatoid arthritis? Recently, scientists, under the direction of Dr. Kusuke Nishioka, have gained new insights into its etiology, while examining the processes of ontogeny and patterning. From a single cell, the modeling of a new life commences. What occurs in the process of ontogeny that gives us a clue to treating rheumatoid arthritis? Let us look closer at the patterning process. Fingers begin to take on form. A cluster of cells at a higher magnification. Intermingled with dividing cells are other cells that are dying. Dying epithelial cells. So that fingers may form, the piece of tissue that held the cells together had to cease being continuous, and the epithelial cells had to die. During the development of the synovial cavities of joints, changes associated with cell death occur. Innumerable cells occupy the entire space, and at this point, a new process begins, the restructuring of the tissue so as to form a joint, an organ whose primary function is to provide locomotion. Dying synoviocytes. They are undergoing a process called apoptosis, the genetically programmed death of a cell. This is what we needed to learn about embryogenesis. The fact that some cells are programmed to die. The patterning blueprint meticulously assigns to each and every cell its program of either life or death, and specifies the exact moment and location of a cell's death. An arthroscopic view of a rheumatoid lesion and its stigmata, the frantic growth of synoviocytes. Violently proliferating rheumatoid tissue has been isolated and transferred onto a medium, and an anti-Fas antibody, known to induce apoptosis, has been added to the culture. Here and there, cells disappear. This is proof that the Fas molecule is expressed in the rheumatoid synovium. The Fas molecule, recognized by the anti-Fas antibody, was first described by Dr. Shin Yonehara as a signal of apoptosis. A cell line derived from the rheumatoid synovium. the cloned cells retain their specific reactivity to the anti-Fas antibody. In exchange for their lives, these cells, undergoing apoptosis, are calling for a new order to be established, one that will redirect the pathological process into one of tissue repair. Apoptosis is a physiological process. A dying lymphocyte can be seen in the rheumatoid synovium. Lymphocytes also express Fas molecules. The cell nucleus deforms. The dead cell was an activated lymphocyte. The exocytosed organelles, encased in cell membranes, may later take on a foamy appearance. Condensation of a nucleus. The nuclear membrane is torn in two. The drifting pieces encase lifeless nucleola. Fragmented organelles are disappearing. Particles of fragmented DNA will also meet their end. Life's end. A macrophage enters on the left, probably interested in engulfing the carcass of a dead lymphocyte. It remains with the dead cell. Apoptotic cell death involves the fragmentation and aggregation of cell nuclei. The death signal was transmitted by the Fas molecule, which had interacted with its antibody. The experiment was a success. Apoptosis was induced in actively proliferating cells. This offers the promise of a treatment for rheumatoid arthritis, the disease until now said to be incurable. Apoptosis is suicidal behavior exhibited by some members of a cell society. The cells turn over, and so does life. Apoptosis, however cruel it may seem, is a necessary life process that reestablishes homeostasis so that life may continue.